Okay, here we are, Wednesday, and it's a big due day for you, right? How are the worksheets coming? Besides the 15 people that showed up in my office today. There's only 11 of you, but... yeah. No. I've gotten a few questions by email, and then a group of you came in today for help, and that's great. So it's due tonight by midnight. You can give it to me on paper, or you can give it to me electronically if you either have a way to scan it in or whatever. I do have people with their phones these days that take pictures of every page. That's fine, but it makes it easier for me if you can put them into one document instead of making me put them all into one document. And you can actually take an image and load it into Microsoft Word and then save it, whatever, and then you could email me that. So individual pictures, it's okay, but it's not ideal. But other than that, electronic is great. So anything else about those? Does everybody feel like they're going to get it done on time? If you have questions, like I said, a lot of this is remembering which function on my calculator was that. Just ask, and I'll let you know. Okay. So today we're gonna continue our discussion of chi-square tests and analysis of two-way tables. But I'm also going to do a lot with technology today. So we're going to use your calculator a little bit. We're going to use Microsoft Excel a little bit, and we're going to use statistical software, the SAS software, which you all have access to through a Washburn server.
Been working getting hooked up on that.
Yeah, so you will, if you've never logged on to the Washburn server, then you'll have to figure out how to do that. It's not tricky, but you may have to talk to the help desk to get the necessary password and all that stuff to do that. But I'll go through that in a second. So, where did we leave off last time?
Chi-squared, the formula of chi-squared.
Yeah. So I ended last time with this chi-square test statistic. Right, and then it was the sum across all cells. And then what was the thing? The expression?
0 minus e over e squared.
Okay. The top is squared, the bottom is not. Right? So what does the O stand for?
Observed.
Observed. And E, expected. Now remember the thing we had on the board over there? You can still kind of see it shining through a little bit. We had the observed counts, and then we computed the expected counts. Okay? Now the one thing that I realized after I left, we went through how to get the expected counts and everybody figured it out, but then you can take what you did to come up with those and give it sort of a shortcut formula. All right? So remember what we did is we figured out, well, what's the marginal probability of this thing? And I forgot to load up, so let me do that. The PowerPoint that had the example problem in it. And this is in a big hurry to get loaded. So let me remember where I was at. There, that was it, right? So it's not very big. I'll hit the That's a little bit better. Okay, so this is a 2-row by 3-column contingency table, a two-way table. It has an extra row of totals and an extra column of totals, the row totals and the column totals. And what did we say those are? We give that a name? The margins, the marginal totals for the table. So remember, when we were computing expected counts, we took the marginal probability of CHD, right, coronary heart disease. So we totaled this row, and we got 190. And then you divide that by 8474, and that gives you the overall probability, ignoring their anger level, the overall marginal probability of having coronary heart disease. All right? Then we applied that percentage to each of the totals for the anger groups. All right? So, for instance, the high anger group had 633 people in them. That marginal probability of coronary heart disease applied to that 633, you just multiply it. Right? So really think about what you're doing. You're taking 190, which is the row total. You're dividing by the grand total to get that marginal probability. And then you're multiplying that by the column total for that particular group. So here's what you're doing. The expected counts for any cell in the table are simply the row total over the grand total to give you a marginal probability, and then multiply that by the column total. So that's a general formula for expected counts. For any cell, you just take the row total for that cell times the column total for that cell, divide by the grand total of the whole table. So if I want the expected count sitting here in the lower left, I take the column total for the column that's in, then the row total for the row that it's in, divide by the grand total. And that'll give me the expected count. Okay? Now, if I remember right, last time we were getting ready to compute the whole thing, and then somebody mentioned that I was like 18 minutes past. Right? So let's do that now. Let's go back to here. And the test statistic, I'm going to let you go to your notes to remind me what all of those expected counts were and the observed counts and all that. And what I want, we've got 6 total cells in the table, right? So this summation is going to have 6 terms. So what I want to do is I want to make a table that has the contribution to this total of each of the 6 cells. You understand what I'm asking? So, for example, in this upper left cell, I want to know what is the observed count, what is the expected count, take that difference and square it, and divide by the expected count, and give me that number. Right? So over here on scratch paper, we'll do that one together. What was the observed count in that cell? So upper left cell, 53. Okay. And then the expected count? 69.731. Okay. And that'll be squared, divided by 69.731. Do that on your calculator. As soon as you got it, yell it out.
4.0
4.014. If anybody disagrees, then sing out. But okay, got it? So now I want everybody to fill in. We got 5 more cells to get, right? So you guys, you 2 up here, do the next cell. You 2 do this cell. And then you 2 in the back do this cell. And then you 2, Brent, and first name? Leanna, that's right. I started to say Deanna, and I knew that wasn't right. Now I forgot where I'm at. It must be this one, right? And then the last 2, Emily and Laura, do this bottom right. So everybody do those, the cell you've been assigned. As soon as you get it, sing out, and I'll write it up here in the table. Then we'll sum it up. We'll get the value of the test statistic.
Got 0.092.
Okay, and which cell are you?
Bottom left.
This one? Point what?
0.92.
0.92. And Taylor, you're supposed to be doing that one too. So
Yeah, I'm getting figure out the expected values and parameters.
okay. Did we wrote them all down in your notes last time, right?
Yeah, but I rounded when I did it, so.
Oh, okay.
3,040.
Right here?
Yes.
0.003. Man, that's really small.
0.145.
And you're here? 0.145. You guys got it?
Upper bike was 11.556.
11.556. That's interesting. Some of these are almost 0. Some are really big, right? And we got one more to go.
0.265.
0. What?
265.
265. Okay? Now, everybody sum all 6 of those together. And I'll write that up here.
$16.077.
16.077. 075. Okay, there's a little bit difference in rounding, but
I have Excel. I had Excel do it.
oh, you're cheating. So, yeah, more accurately.
So if you want to like a billion decimal points.
0.075. If we stop at 3 places on each of them, right? Okay? But do know that the software is always going to do it the more accurate way. And so, now, that's the value of a test statistic. Now, we didn't really talk about this much when we were doing our 140 review, but so I said this to some of you in my office today. A test statistic always works similar to the way this one works. You take what you would, you take what you got in your sample, your observed values, and then you see, well, how far away from what you would expect to see if the null were true? And then you form a test statistic out of that. For a means problem or a proportions problem, it's always just number of standard errors that the observed data is from the expected value. But at chi-square, it doesn't work that way. This number, 16, is not 16 standard errors away. It's not. So there's really no great interpretation of that number. I cannot look at 16 and go, wow, that's big, or wow, that's small. It's just, it's 16. So we need to have an idea of whether that's a significantly large value or not, right? Well, the chi-square, similar to a t-distribution, has degrees of freedom associated with it. Did we talk about degrees of freedom last time? Do you remember how to get degrees of freedom?
N-1.
Nope. It's n-1 for means problems, but for two-way tables, nope. Good guess, but it has to do with the number of rows and the number of columns. So degrees of freedom in a contingency table. I'll just hit page down, and then I'll come back to that page. Think about, for any size table, so let me make a different size table. Let's go 4 by 3. Or actually, it's 3 by 4. This is a 3 by 4 table. 3 rows, 4 columns, right? The degrees of freedom, think about that freedom. If I fix the totals, so this is row 1, row 2, row 3. This is column 1, column 2, column 3, column 4. If I consider those numbers as fixed, remember we did this when we did expected values? We said, okay, those are fixed. Now fill in a table that makes the null true. Well, how many of the cells do I have to fill in before I can get the rest by subtraction? That's degrees of freedom. How many of these cells are free to fill in any number you want? The rest of them are fixed. So let's do it. If I fill this number in, can I get any others by subtraction? No. How about I add another one? No. Add another one.
Yes.
Now I can get this one. And no, I'm not playing tic-tac-toe. Right? Okay, now if I fill this one in,
Yes.
now I can get this one. But I can't get any of the rest. Right? Fill that one in. Now I can get that one. Fill this one in. Now I can get the rest. I can get this one. I can get this one. Since I've got these two now, I can get this one. Right? So there are 6 degrees of freedom. So the degrees of freedom are the number of cells you can fill in freely before all the rest are determined. And it's simply take out one row, take out one column, and the product that's left. So degrees of freedom are rows minus 1 times columns minus 1. So R for number of rows, C for number of columns. The degrees of freedom, R minus 1 times C minus 1. So this is a 3 by 4. So degrees of freedom would be 2 times 3, or 6 degrees of freedom. Okay? So you don't have to draw this tic-tac-toe board every time to figure it out. You just say, well, it's the number of rows minus 1 times the number of columns minus 1. That's degrees of freedom. Okay, so now back to this. How many degrees of freedom do we got? Two degrees of freedom. 2 rows, 3 columns. Number of rows minus 1 is 1. Columns minus 1 is 2, so 1 times 2 is 2 degrees of freedom. All right? So now I've got a number and a degrees of freedom. Well, the chi-square distribution is a skewed distribution that depends on the number of degrees of freedom as to how much skewness there is. Then the critical values for a chi-square distribution are the values that have a certain amount of tail area out there. So for alpha equal 0.05, I would find a critical value that had 0.05 out in this right tail. Right? Well, I've got 16 point, forgot the number. Oh, here it is. 0.075. And that neither one of those look like the right value. I have to be careful with this. My normal perfect handwriting doesn't seem to work. Okay? So the p-value for the test is the area out in that tail. Remember the definition of p-value? It's the probability you could get a test statistic like you got, or even more extreme. So shaded, it's that area. So how do I get that area? 2 choices. You look up in the chi-square tables in the back of your book. And since the degrees of freedom, there's lots of possibilities for degrees of freedom. You just go to the chi-square table and find your degrees of freedom, in this case 2, and look up the critical value to see how much what's the critical value for, say, 0.05. And if it's a number like 14, then this would be significant because it's further out than 14. easier thing on your calculator to get the p-value, you have an xCDF function, or an x squared for chi-squared. So go to second function, vars button, under distributions, and scroll down till you find one that looks like the calculator's best attempt at a chi-squared, and then it'll have a dash and CDF. Or I don't know if it has a dash. No dash. Okay. Okay, so what do you enter into that? All of the CDF functions on these calculators, you enter the left edge of your shaded region and the right edge of your shaded region, and then degrees of freedom or mean and standard deviation, whatever the parameters are. So for chi-square distribution, the parameter is the degrees of freedom. So what's the left edge of my shaded region? 16.075. And comma, or if you have a newer version, it probably is in rows, it'll say area. Is that what the first one says?
Lower, upper.
Oh, lower, upper. So this is lower. Upper is what?
Lots of nines.
Lots of nines. Infinity, right? So you just need a really big number. You can put 1E99, or you can just go 9999. It looks like Q's, but they're nines. This thing keeps writing even as you start to pull it away, so it gets the little tails on there. And then 2 degrees of freedom. Okay, so what do you get for that number?
0.000323.
0.000, another 0?
Yep.
0, and then 23? 323. All right, conclusion?
It's way out there.
That's way out there, right? So that's this value. Now, I can never remember what to do with that p-value. What is the p-value again?
The chance of getting data similar to observed.
If the null is true, right? So, in other words, it's a measure of how likely it is to get the observed table that we got if the null was true, where we would expect to get the expected numbers, right? This is not very likely. So that's pretty much 0 probability. There's 0 chance you could get the table you got if the null was true. So what's your conclusion? Yeah, the null can't be true. So you accept the alternative, you reject the null. If I can't get data like this when the null is true, since I did get data like this, the null must not be true. So you reject it, right? Now, here's what a p-value is not, but it's okay to think of it this way. This is not the probability that the null is true, but you can think of it that way. This says it's really, really low probability that the null is true, so I'm going to reject the null. Right? So there's a lot of dead statisticians rolling over in their graves when I say that, probability that the null is true, because it's really not that, but it's okay to think of it that way. It's just turning the conditioning the other way around. But it's okay. It's kind of how our brains work. Okay, now, let's do the same test using your calculator to do it all automatically for you.
Sweet.
Yeah. Oh, thank God. Because even a fairly small table like this, there's a lot of steps to get to here, to get to the conclusion. Oh, I forgot the conclusion. We reject the null, but what's the conclusion? Remember, the conclusion needs to be stated in the context of the problem. This was anger level as a predictor of coronary heart disease. The null says, what's the null hypothesis in a...
The null was that there was no association.
No association. We're going to reject that. So we're saying
There is an association.
we have strong evidence to say there is an association between anger level and the risk of coronary heart disease. Okay? Now, to your calculators. Let's see. Let's do this. So, on a TI-83 or 84. First, you enter the observed counts in a matrix. Enter observed table into a matrix. And to find a matrix, I can't remember the sequence of buttons, but it's second function, and then there's the word matrix. Oh, it's above the X symbol. So second function, and then X inverse button, right? And the word matrix is written up above there, right? So then when that pops up, at the top, it'll ask for the dimensions of the table. And the first time you've ever used it, I think it's 1 by 1. I don't know what the default is, but you change it to whatever matches your table.
Should we go to edit? Because that's what shows up.
Oh, yeah. Thank you. When it first pops up, is not what I just said. When it first pops up, you get 3 menu choices. Names, and then calc. What was the middle? Math. And then edit. And you want edit. Names is just a way to put the name of a matrix into an equation on your other screen, right? And we won't be using that. Math is if you want to do matrix manipulations, like find the inverse of a matrix or multiply a matrix by, and we don't need that either. You do when you take MA341, but not this, all right? So pick edit, then you set the dimensions of your matrix. For this one, it's 2 by 3. So enter a 2. Press enter, it'll jump to where the 3 should go, put a 3, hit enter, and it'll jump down into the matrix. And it'll change the size of the matrix to right? So now you enter your observed counts, which I don't have written anywhere. I had them, actually, if I hit this, they're too small probably for the screen, but just enter the numbers as they appear here. 53, 110, 27. Then 3057, 4621, 606. Do not enter the total or the total row. Right? Those are not part of the matrix. That's a common mistake, is to say, oh, I've got 3 rows and 4 columns, and enter the 3 by 4 matrix. But remember, these are margins. They're not part of the table. So it's 2 rows, 3 columns with those numbers. Right? Once you get it entered, you're done with that screen. Now you're ready to do the chi-square test. Oh, one thing I forgot to say is use matrix A. Did everybody enter them into matrix A? That's the first one that pops up. As long as you always use matrix A, then you don't have to figure out how to use the names thing on the next screen. So here comes the next screen. Push second function, push stat, and then test. Okay? So enter numbers, and then push the stat button, and then go over to tests, and then go down to chi-square test.
So just a 2-way test? Because mine has like a chi-square GOF.
Oh, yeah, yeah. What's the other one say?
A chi-square 2-way test.
2-way test.
Yeah.
Okay, so you got a new fancy, Inspire or something?
Yeah.
Okay. The TI-83s or 84s don't have the 2-way thing in there. They just say this, right? There is, but you do have the GOF.
Yes.
And the GOF stands for Goodness of Fit. That's section 9.2. So we'll do that on Friday. All right? So this one is chi-square test. Then when you hit enter on that, it's gonna pop up the word observed. This is going from memory, but the word observed, then a colon, and then the name of a matrix by default is A. Right? As long as you use matrix A, you don't have to change that. But if you put them in some other matrix, you have to change it here, and that's where you have to use that names function. Right? And then expected is where you want the calculator to store the expected counts for you. It'll compute them all and store them into matrix B. So the only thing you have to do on this page is go down and hit calculate. And you should get as your results the same thing we got here. You should get a test statistic of 16.07, probably a 7, not a 5, because it's going to keep more decimal places. And you should get a p-value that looks pretty close to that one, within round-off error. Okay? You think that was easier than doing them all by hand?
Yes. It's like 2 minutes. So, like mine again has like an exponent matrix or comp matrix.
What?
Mine has more things that are just like dots on there.
Oh, it's probably showing you the observed counts or the expected counts, and it can't show them all on one screen.
Oh, okay.
Expected, and I don't know, computed maybe? I don't know. But now, if you want to go back and look at the expected counts, go back into your matrix functions, go second function matrix, go over to edit, and now go down and select matrix B, press enter, and boom, there will be your expected counts. All right? Everybody got it? Okay, now, this reminds me to discuss the online homework tool, which is called Launchpad. I've already sent you guys an email about Launchpad, right? About the book and the ebook and Launchpad and all that. The first assignment is now up in Launchpad. And it will be due, I think I put next Monday, right? And so each week in this class, each week we will have homework, and all of the homework that's assigned in 1 week, or all the sections that are covered in 1 week, that homework will be due the following Monday, right? With exceptions if we do something weird, right? So the first one is due in Launchpad next Monday night. So you'll need to, if you haven't already bought your code and gotten registered and all that, you need to do that soon so you can start on this homework. There's quite a few homework problems, right? So I believe I put 9.1 and 9.2. Are you looking at it?
Yeah.
As 2 separate homework sets?
Yeah.
Right.
So there's like 9.1 homework practice, then 9.1 homework graded.
Ah, yeah. I'm glad you said that, because the one that's, and I think I might have mentioned this the first day. I don't know, but there'll be 2 of each. One is labeled practice, and one is labeled graded. The one that's labeled practice, I put unlimited attempts. Show them a solution after every attempt. So if you get it wrong, it'll show you, here's how you work that one, right? So you can do whatever you want, but that one is worth no points. So then when you go to the graded one, okay, now you get 1 attempt, right? So you make your attempt, you enter the number, it'll show you the solution and the correct answer again, but you don't get to try it over, right? So go through the practice ones. If you get them all right, or you feel like, okay, I know what I'm doing, then you go to the graded one. Yep.
Do you know if, like, so once you start the graded one, like, say I do like 2 problems,
yes,
go back and do the practice ones for like more?
Yeah, you can do that. It's called save and exit, right? So, and that's a choice that I get to make when I set it up. Allow them to save and come back later, and I said yes, allow that. So you can save, go back to the practice, work on that a while, then come back into this one, and pick up where you left off. Okay? And the first few of these that we do, there will be a learning curve of figuring the system out and all that stuff. So feel free to email me with questions as you're doing them. I don't remember on this system if there's a way to click a button and ask your instructor or whatever. If not, everybody's comfortable with doing screenshots. You know what I mean by a screenshot? Right? You capture the screen. If you don't know how, there's usually a button up in the upper right corner that says print screen or something. So you hold the Alt button down and hit print screen. If you're on a Mac, it's like
Command 3.
Yeah.
Command, Shift, and 3. And then you just open an email note and say paste, and it'll put that image into an email that I can see what you're looking at. Okay, say here's my question. I don't know what to do with the 5. Whatever your question is. Okay? And I'll answer those questions. So, all right? So, you are free to use your calculator or Excel or whatever as you're doing the homework. But using like Excel or SAS, which we're going to get to, those things are tough to do, but you just open a different window and have it working over there, and then you can toggle back and forth, and it works okay. Right? So I want to pull up Microsoft Excel. How much time do I got? Not as much as I need, but almost every week there will be the Launchpad homework, and there will be some software homework. Right? It'll say, do this problem using Excel, or do this problem using SAS, right, or something like that. And then those you'll just submit to me outside of the Launchpad system. You just send me an email with an attached Excel spreadsheet or whatever. Okay? So, let me pull up. I have an Excel spreadsheet that I've already started for this coronary heart disease problem. So, to make this,
it should be basically
everybody's jabbering, so I assume that you're trying to help figure out where Excel is. Is that what you're doing?
Yes.
Okay, that's fine. So I've zoomed this way up, but this is just the table, right? Now I don't have it out there yet, but I will make stuff like this available to you on D2L. Say, here's the data you're going to need for this question. It probably won't be this question, but one like this, right? And then what I want you to do, and this will be due next week. I don't know if it's Monday. I may make it like Wednesday or whatever. But do what we did by hand to do the chi-square test. Okay? So make it a table over here or down there or whatever that has expected counts. So this will get you a little bit. How many people have never used Excel? 2 of you? 2 of you never used Excel? Okay. So you may need a little bit of help even beyond what I show the class. But I've worked this one already. So let me zoom this one up a little bit. Is that big enough to see? Yeah, let me go a little bit bigger because of the screen or the projector. That thing. So here's my observed counts. And the previous one that I showed you did not have the total rows in it, I don't think. So to compute things in Excel, you use what are called cell formulas. So if I click on, oh yeah, I can click with my finger. If I click on a cell, this row total, notice, has an equal sign. So in Excel, an equal sign means here comes a formula. Right? So here comes a formula. I want to use the sum function and sum from B3 to D3. So here's column B, row 3, B3, C3, D3. So sum those things, put it in that cell. Right? And then once you get a cell, you can copy and paste cells into other cells, and it will automatically adjust to the next row. Sometimes you want that, sometimes you don't, so you can control that with a dollar sign. Dollar signs fix things. But if I go to this cell, then now it's sum of B4, D4. If I go here, it's sum of B3 to B4, B3, B4, and so on. So those are my totals. Now, how do I get expected counts? Well, remember, it's row total times column total divided by grand total. I just computed all my row and column totals. So for this cell, it's B5 times E3. Wait. B5 is the column total times E3, which is the row total, divided by E5, which is the grand total. Now, notice the strategic placement of dollar signs in there. So it's B.
That's okay. Just highlight for you.
Yeah. So B $5 means don't change the 5 when I copy and paste this, right? You can change the B. So it's the 5th column. So the 5th row. So that's this row of totals. So it's saying stay on that row when I move around in the table, but let the column move if I come over to this column for example, I have to hit escape or that'll mess me up. But if I come over to here, there. Then it moved to column C, but it left the 5. So the dollar signs are to help you copy and paste without having to retype the formula every single time. But that would always work too. Okay, so expected counts. Get them by figuring out which ones you multiply and divide by. No problem. Okay, contribution to the chi-square for each cell. Hey, that's what I had you guys do in pairs, right? That's observed minus expected. So B3 minus G3. Okay, wait. Here's B3. That's observed minus G3. That's the expected count that corresponds to that same cell. Quantity squared, so parentheses, caret 2, divide by G3. And G3 is the expected count. Then I do that across all of those 6 cells. And then my test statistic, sum up B9 to D10. So B9 is here, D10 is here. It'll sum in that range of cells. Man, this is easy, right? And then degrees of freedom, I just entered that myself. I was trying to figure out how to tell it to count how many columns and all that, and I wasn't that smart. So I just enter a 2. So you can do it mentally, figure out what your degrees of freedom are, enter it there, and then the p-value, there's a function in Excel called chi-sq.dist.rt. Okay, the chi-square I got, what's the dist? Distribution, what's the RT?
Right tail.
Right tail. Right? So, and then you enter B12, B13, let's see, B12 is my test statistic, comma, degrees of freedom.
Is
Yep.
that an add-in or a formula?
It's a formula. Yeah, you don't have to add it in. It should already be there. Okay? So that gave me, and notice that the value is the same number we were getting when we did it by hand within round-off error.
Could you re-highlight the cell again so I can see the formula?
This one?
Yeah.
Yeah. So you start with an equal sign, and as soon as you start, and in fact, let me go to a blank cell, and I'm going to start typing. I'll type an equal sign, and then I'll start typing chi, and look what happens. Excel does this, says, oh, you want one of the chi-square functions. So it gives you a list of them. It makes it easy to find them. You don't have to remember how to spell it, right?
I think if you click on the formulas tab, you can click on statistics or something.
Right. See this little FX out in front? You can also do this by clicking that FX, and then it'll pull up. It first pulls up, says, well, what kind of function do you want? And one of the choices is statistical. So you click on it, and then it'll list all the statistical functions there. But I find this easier. As long as I can remember the first couple of letters, I can usually narrow it down. Right?
What was the RT for again?
RT for right tail.
And it gives a description in Excel.
Right, and over here it says returns the left tail. Oh, that's on the wrong one. But returns the right tail probability of the chi-square distribution. So there is no LT. Without it, it's LT. With the RT, it's right tail. Okay? Okay, now, look at this cell down here. Same exact value as that p-value. But if I click on that, it says chi-square.test. B3 to D4. B3 is here, D4 is here. So that's observed counts. So chi-square test, observed count range, comma, guess what that one is? Expected count range. So Excel's not as smart as your calculator. Your calculator computed the expected counts for you. So all you had to do was enter the observed counts, tell it to do the chi-square test. Here you have to compute the expected counts, but once you have them, then there is a function you can use to do the test, and it just gives you the p-value. It doesn't give you the test statistic. If I ask you to compute the test statistic, you can't do it with this function, but you can get the p-value from that function.
And Excel will tell you as you type the formula, like what you're supposed to type in.
Yeah.
Like it'll say expected counts, And then we'll have a comma, and then we'll turn it the other way around, reserve, comma,
Right.
expected.
That's a good point. Let me come back into this one. Chi.test. How come
You
it?
have to do the square, don't you?
Oh yeah, I started getting too smart for it. And if I click on that, if I double click on it, it'll put it in there, and then it gives you a little hint down here. Actual range, comma, expected range. So it's telling you what the things you're supposed to give it are. So actual range means the range of cells where your actual counts are. Actual and observed means the same thing. And then comma, give the range where your expected counts are. Got it? So that's Excel. Okay, now let's go. I'm not going to get much into SAS here, but I want to at least get you started. If I want to use SAS, then we need to use the WooStat server. And you can get to the WooStat server from a remote desktop connection on any home computer. Okay, so actually let me use the board over here. The address is shown there. Has everybody used a remote desktop connection at some point in their life? Okay. Leanna's saying no. You're saying no. No. Okay. So remote desktop connection. If you're on an Apple, I have no idea.
Cord.
I think
You can use cord.
What?
Cord, C-O-R-D.
C-O-R-D. Okay. Cord.
Yep.
Okay. And then it'll have something kind of similar. And it's asking me first, what computer do you want to connect to? And so the address that you need is WooStat, WUSTAT, period, Washburn, period, edu. Okay? And then there's a down arrow and options. The first time you do it, you'll probably want to play with those options. It gives you a bigger window, and then it says, none of this matters a whole lot. You can set display to tell it to use the full screen or make it a window. But the one that's important is local resources. All right? So down here it says local devices and resources. Put a check in printers. If you have a printer that you want to print to, while you're on the remote desktop, it'll use your own printer. Right? And clipboard. And this is the one I think is more important. Put a checkbox in clipboard. And then if you copy and paste, you can copy in the remote desktop, toggle back over to your own desktop, and paste. So it's a way of getting stuff off of this Washburn server onto your own PC. And then if you click on the More button, then put a check mark in Drives, and it'll be able to see the hard drive in your own computer. So you can access that while you're in your remote session. Right? Sometimes that's useful. I don't use it a whole lot, but once in a while. Okay, so I'll just say cancel there, and then let me go back to General, the woostat.washburn.edu, say connect, and you get this little login screen. So you'll enter your credentials for the WooAd/WooStat server. Okay, so what are my credentials? Well, your credentials, you'll have a username. Mine's really old, so it starts with a ZZ, but it'll probably be first name dot last name, the same as your Washburn email address starts. Right? So it'll be Brent.West. Okay? But you need to make sure it has this WooAd in front of it and a slash. And probably the first time you go in there, it won't, since I've used it before, it already pre-populates with that. But the first time you go in, it'll be blank like this password is blank. Right? And if you don't know the password for the servers, I don't believe it is the same as your email password or your My Washburn password. I think it's different. So you will have to contact Bennett 104, and I don't know if they'll do it over the phone. They will?
When I got on there, it was either like, I think it was my actual just login password.
Okay.
Or maybe it was the first one I used, but I've only switched back and forth between like
I
three
think
of
it
them.
should be like the one if you like log into the library that
Yeah, I do know that is true. If you've ever logged on to any walk-up machine on Washburn campus, like over at the library or a computer lab or anything like that, it'll be the same login name and password that you use for those. And if you don't know what that is, you've never done that, then contact the help desk, which is at extension 3000, or just go to Bennett room 104.
It's just your Active Directory credentials.
What's that?
It's your Active Directory credentials was asking for it.
Okay.
Those are, which is
Yeah.
usually default to the email ones.
Yeah, okay. And then you just enter your password and you'll say okay, and you'll be on a server that has SAS on it. So next time, we're going to do this same problem using SAS. Okay? We'll see you then.
So is SAS kind of like SPSS?